Here is the question of free will as I understand it. Some things are out of your control, like where you're born, or how rich your parents are, or the weather. But once you become an adult and start making decisions, your actions are a result of your decision. You control what you do. That's free will. Once you reach the capacity of making your own decisions, you do, and you control your life and what you do. You are in charge. Or are you? What if I told you a radical idea that free will doesn't exist? Like, sure, the entire universe and everything in it is predetermined by a set of equations, but you're really special and you have free will? I don't think so. Oh my God, did we just cancel free will? I'm joking, but I do need to tell you that I read 3 books for this video and I watched a bunch of philosophy lectures, and every single piece of media I consumed had some line about, isn't this idea shocking? Aren't we all shocked? People have been having the discussion you and I are about to have on this video for thousands of years. Like, it's not crazy or radical. Like, it's just a school of thought. It's such a weird way to frame your lecture on free will, to be like, but what if you don't have free will? Like, yeah, dude, we all went to high school. We all smoked pot in a field. We've had this conversation before.
I don't think so. No, 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 no.
Anyway, I think it's obvious that there is a philosophy component to the question of free will. Morality is wrapped up in whether the choices we make are our own. Can you punish someone for committing a crime they had no choice in? That is a question that comes up if humans don't have free will. There is a lot of philosophy I do like. I mean that sincerely. A lot of philosophy, hot take, is really interesting and good and fun to read. When I was an undergrad, my minor was in philosophy because I was doing this weird scholarship where I would get like $200 a semester and I would replace all of my electives with like philosophy courses, which like isn't a great idea because liberal education is a good thing, but I did read and enjoy a lot of philosophy. But the thing is, a lot of modern philosophy is just nonsense. I'm going to give you an example from one of the books I read. This book is called Determinism and Free Will: New Insights from Physics, Philosophy, and Theology. And the philosopher in this book is called Emmanuel Severino, and I will read you a passage from his section. These questions underline the central thesis of my philosophical inquiry, that every state in the world, every part of every state, the content of every instant, every entity, and therefore every event is eternal. To be eternal means that it is impossible for it not to be. The impossibility is not ascribable to any other form that impossibility has taken in the wisdoms of the West, therefore not even to the meaning that scientific knowledge confers upon this word. It is, however, interesting to note that there is a way of interpreting the theory of relativity as an affirmation of the eternity of every state in the world, and that Einstein did not oppose this interpretation. What does this mean? For Einstein, the experience of this transition from not being yet to being no longer is illusory, since in my writings it is shown that experience does not attest and cannot attest to the transition from what is not yet or what is no longer. These writings thus show that experience is not illusory. Therefore, since every being is eternal, the variation of experience is the appearing and disappearing of eternities. It's just that it's baffling and it makes no sense. It's just word salad, words in a row that I know the meaning of separately, but when you smush them together, it's like, what are you trying to say? And what is your misunderstanding with relativity that you think it's about eternities that aren't eternal? It seems to me that philosophy, like a lot of other places in academia, including science, are suffering from the publish or perish mentality, and they'll just print anything. What really gets me about a lot of modern philosophy is that it's all about definitions. Like he specifically is like, in my other works I have shown, and he's just defining word after word after word in such a way that you no longer understand what he's talking about. And then it's impossible to critique, right? Because if you don't understand what he's talking about, anything you say, he can just refute it and be like, well, you don't understand. It's impossible to understand because you, sir, have made it needlessly obtuse. Like, it makes no sense. But I'm not a professional philosopher. I cannot pretend to, like, differentiate between crackpot nonsense philosophy and actual philosophy. So I'm not going to do that. I'm not going to talk about philosophy. I did read a little, like, airport book. Why am I so bad at showing books? It's called Free Will, A Very Short Introduction by Thomas Pink. And this was fine. Like, it's just the history of the question of free will. It has Hume and Hobbes and Kant and it goes through it, and like it was readable. The words made sense in the order that they were written, and it was fine. But it's philosophy, and that's not what this video is about. But the thing about philosophy questions is that sometimes philosophy questions are philosophy questions, and then science advances, and the philosophy questions become science questions. Can you break something down so small that it cannot be broken apart again? That's a quantum mechanics question now. It used to be a philosophy question. Or do we have a soul? What is consciousness? That used to be a philosophy question, but now it's like a neuroscience question, right? So, is the question of free will a physics question? No, I don't think so. Thanks for watching. Like and subscribe. Join my Patreon. I'll see you guys next time. I've always wanted to do that joke. I'm so sorry. I'm sure you knew it was coming. Let's get into it. So there's a mathematician called Laplace, Pierre Laplace, I think. And you've heard of him because of the Laplacian. And he's one of those ones that did like many, many things. But he has this very famous quote, I guess. He wrote a philosophy book about probability, and I will read it to you now, just the quote part. We may regard the present state of the universe as the effect of its past and the cause of its future. An intellect which at a certain moment would know all the forces that set nature in motion and all the positions of all items of which nature is composed, if this intellect were also vast enough to submit these data to analysis, it would embrace in a single formula the movements of the greatest bodies of the universe and those of the tiniest atom. For such an intellect, nothing would be uncertain, and the future, just like the past, could be present before its eyes. So this is called Laplace's demon, but I don't think it's a good name. It's not like Maxwell's demon. But anyway, in modern physics language, Laplace is presenting the idea of if you know the initial conditions and you know the laws of the universe exactly, you could predict the motion of the system. You could predict exactly how everything will evolve. This is called determinism. It's a physics idea. A lot of people take this quite literally, and I don't. And I also don't think Laplace would either. Some people think that this is true. Like, if we could just keep making better computers, if we had a quantum computer, we could eventually predict the future by putting every single star as a little dot in the simulation. And I don't think so. Let me read the continuation of Laplace's quote. All these efforts in the search for truth tend to lead the human mind back continually to the vast intelligence which we have just mentioned, but from which it will always remain infinitely removed. We won't ever be the infinitely intelligent being that can calculate everything in the future, according to Laplace. So a lot of physicists at the time, not because of Laplace, just because this was how people thought at the time, agreed with this idea. Like, we understand the forces, we understand how particles will move under these forces. The future must be determined. And when you interpret determinism inside the free will question, you may think, well, if everything is determined, how can we have free will? If everything is set in motion and governed by the laws of physics, isn't that the case for Earth? Isn't that the case for the organism on Earth? Isn't that the case for our brains specifically? Are the teeny tiny particles inside of our bodies obeying the laws of physics in such a way that the decisions we make are already predetermined and free will doesn't exist? That's where physics comes into the free will question. But don't worry, something amazing happened. It was quantum mechanics again. Just busting in and lowering the expectations of physicists. Oh, you thought physics was solved? You thought you could always have the answer? Quantum mechanics got them. So quantum mechanics, you guys know of it. I don't need to explain quantum mechanics, right? Like, quantum mechanics is probabilistic in a way that classical mechanics is not. And you can predict the statistical likelihood of an event, but not really the event itself. So determinism at the smallest length scales must not be true, right? Because quantum mechanics is random. There's chance there. So free will is saved, I guess, by quantum mechanics, except I don't really understand this. Is chance the same thing as free will? Like, do people accept that? Do philosophers accept that? Like, do people seriously equate probabilistic chance at the quantum level with free will and morality on like the human level. That seems odd to me. But I'm not a philosopher. Anyway, physicists don't like quantum mechanics. That's a broad generalization, but you know what I mean. Physicists like symmetries. They like neat little beautiful equations. Quantum mechanics is probabilistic. Quantum mechanics means you do an experiment and you know about what will happen, but you can't ever say for sure because quantum mechanics is probabilistic. Your average physicist is annoyed. I can't predict everything. Everything's not deterministic. Like, everything is just wave functions that collapse into a statistical solution. Like, that's the answer. Anyway, it's that trope, you know, of physicists want things to be beautiful, and quantum mechanics just isn't as beautiful as getting the correct answer every time. So physicists have been trying to overcome this. They would much prefer physics to be deterministic, for them to get the right answer every time and have it not rely on probability, because it just doesn't seem nice. Which, again, that's not my logic. That's just kind of... So, since the discovery of quantum mechanics and its probabilistic nature, people have been trying to overcome this. They would much prefer it to be deterministic. And you've heard of these things that people have been talking about for 100 years, like spooky action at a distance, and the EPR paradox, and Bell's theorem, and the Copenhagen interpretation. Like, there have been many, 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 many conversations and papers and thought experiments and real experiments trying to understand, like, is this probabilistic thing a math thing or a real life thing? Okay, this is a question physicists spend a lot of time on and are very invested in. Remember that. So this is where we're at on the is free will a physics question thing. Not really, but determinism is a physics thing, and some people relate it to free will. I also read a book by Sam Harris called Free Will. And I have read this before. I read it like 10 years ago when it came out, and it was fine. So he hands you the definition of free will and has a discussion on it and morality. And then he talks about modern neuroscience experiments where scientists hook people up to machines that read their brain signals, and they find things like your brain knows you're making a decision before you in your brain have realized you're making a decision. So you're sitting on the couch watching a movie and your brain sends a signal to your body that you are going to pause it and get up to pee. And a measurable amount of time later, you think, I'm going to pause it and get up to pee, and then you do. According to Sam Harris, in this book, those experiments prove that free will doesn't exist. Every action you take is predetermined by your body signals, and you just kind of get tricked into thinking you've made a decision. There is a weird thing I see in these books with philosophers and neuroscientists where they separate you from your body, which is something I just don't understand. Your brain sends your body the signal that you have to go pee, and then milliseconds later your brain goes, I have to go pee. All of that was you making the decision. Like, just because you experience the thought after the action doesn't mean you didn't make the decision. I just find it really weird. I don't understand why these experiments suggest there's no free will, because, like, that's still you making the decision. Like, he talks about your bacteria inside your body, and he's like, is that you? Your bacteria does, and it's just like, yeah, because if you took out all the bacteria, I would die. And even our cells have mitochondria, which is like a foreign object that was microphaged into the human cell, and that's in every single cell. And like, yeah, that's me too. I don't understand that perspective. But like, the book was fine, and I do think, do we have free will is a how does the brain work question, and it's not the place of a physicist to answer that question, because I do not study or know anything about the brain. You can see from the brief statements I've just made. Are we truly making our own decisions? Sam Harris says no, but I don't think that is a conclusive answer. And I also would compare how does the brain work to Laplace's demon. The brain and the interactions of the cells within inside the brain are just too big of a computational problem. Also, I reference that thing about philosophers like refusing to critique other people's work because they're like, well, you just misunderstood the definition. Daniel Dennett, who is like also, I don't know, these were like the skeptics. That was a whole thing on the internet, whatever. Daniel Dennett reviewed this book and he was like, it's a fine book. He makes a solid argument for what he thinks he's saying, but he just doesn't understand compatibilism. And if he understood the definition of and it's like, oh, philosophers are exhausting. So, is the free will question a question of physics? I don't think so. I think it's physics related via determinism, but in the end, it's like a brain doctor question. I am not an expert or even an amateur in the world of neuroscience, and I know that there, like physics and like philosophy, there's a lot of garbage neuroscience research out there, so I'm not going to speculate. I'm not going to pretend I can decipher which are the good and which are the bad, so I'm just going to leave it at that and say it's a brain doctor question, and that ain't me, though. I'm so sorry. Gerard Hooft. Is that correct? That's who we're going to talk about now. He's a theoretical physicist, and he won the Nobel Prize in 1990. Quantum structure of the electroweak interactions. There you go. Lately, he's been talking about the interpretation of quantum mechanics. So that's actually why I bought this book, for the essay by Gerard Hooft, and it was good. The absolute only thing worth reading in this book was the essay by Gerard Hooft. Let me read you something from the introduction of this book. The introduction of this book was by Fabio Scardilli, and he is also the editor of the book, and I think he hosted the conference. But, he's a physicist. With his philosophical research, Severino thinks he has provided a foundation for the eternity of beings, the eternity of each single entity, of each single event. This vision is undeniably similar to the vision proposed in general relativity, in which all events, past, present, and future, have always coexisted and will do so forevermore, remaining eternally as points on the space-time manifold. That's nonsense. That doesn't make sense. General relativity, one of the big things is causality, where events have causes. That's how you get a speed limit on C. I'm not saying Fabio Scardilli doesn't understand general relativity. I think he's trying to write something that sounds philosophy, and so I'm confused. I'm confused by what he's trying to say. And I did Google that, and a Medium article about a Brian Greene video popped up. So I wonder if he's confused by something he heard Brian Greene say, a man who also understands general relativity and causality and how events have to come after the thing that caused the event, and so you can't have, it's fine. And I guess that's just nitpicking, it's just a sentence that doesn't make sense. But this sentence, also from the introduction, again, this is not Hooft, this is the guy who set up the conference. In fact, one of the most debated and paradoxical results of quantum research in recent years is the so-called free will theorem. This proceeds roughly as follows. First, the authors Conway and Cochin give a formal definition of free will, which makes it possible to quantify the degree of free will possessed by a particular entity. Then they analyze a Bell-type experiment and demonstrate that on the basis of commonly accepted QM principles, the observed electron must have the same degree of free will as the observer who performs the experiment. And in no way is this one of the most debated results of quantum research in recent years. This so-called free will theorem is very much a thing that exists only on YouTube videos and Wikipedia pages and a bunch of single-author quantum physics philosophy papers of people arguing back and forth. The free will theorem is not the most debated results of quantum. Oh my God, is it a result even? It is strange to me how a lot of these quantum philosophy papers are retorts about definitions with single authors. It is silliness to live when to live is torment. Anyway, I did say Hooft's speech was very good and also the only thing worth reading in this book. He describes what a theory of everything is and what it is not, which you have to remember he's giving this talk to a philosophy audience, so I think it's really nice the way he does it, and he outlines without any math the quantum mechanics problem I just presented to you and how it relates to free will. And then he does a little Gedanken experiment, which I will speed through for you right now. First, he says, imagine you're God, and you are going to open up your laptop and make the universe exactly as we observe it today. To do this, in the simplest way, you would make some demands on your universe and you would set the rules of your universe. First, the demands. Number 1, the rules must be unambiguous. At every single moment, what will happen next must follow from the rules uniquely. So there's an exact prescription about what happens at each step. The second demand is that we must have causality. Everything that happens must be because of something that happened in the past. And the third demand he makes is about efficiency. So not all events predict the future, but some do. And he very specifically mentions that this puts a power demand on God's laptop. Like, you have to limit the region of interaction of particles, and this demand leads to the rules. Rule 1 is locality, which is obviously coming from our demand. In order to determine the future behavior of an object, you only need to know about the objects in some sort of vicinity. So kind of like setting a radius of influence on your objects. Rule 2 is about velocity. The way objects behave at rest should be very, very, very similar to how they behave in motion in a straight line. This is inertia, right? Rule 3 is that there is a speed limit c. And this can come from rule 1, right? If you have locality, the object is only influenced by objects in a certain region. That means there is a speed limit. There is a limit to how fast data can travel. So things further than c are not influencing the objects in your little region, right? So from this rule 3, that there is a speed limit called c, you get all of relativity, right? All the fact that there is a universal speed limit is how Einstein developed relativity. So you get like time dilation, meaning things that are moving faster experience time more slowly. You get length contraction, so things that are moving very quickly will shorten in the direction of motion. And you also get that, like, the clock speed, the way things experience time, will depend on the velocity of the object. When we're thinking about the power demand on the laptop, you get rule 4 as well. Rule 4 is that matter must be quantized. You can't keep breaking your thing down into smaller and smaller blocks because that's going to complicate the equations of the simulation you're running. So there must be some smallest unit where you stop. Rule 5 is about forces. Like, we understand how things are moving when they're in a straight line, but what if they're on a curved path under the influence of some object? In order to evolve your simulation, you must understand the forces completely and how they will affect the movement of the objects. Rule number 6 is that you, your God, must have a complete description of the initial state. And rule number 7 is just run this simulation, follow the rules, and you will predict exactly how everything will happen. And this, he says, is an obvious train of thought on how the universe works. And from this, we do get all of the laws of physics as we understand them, right? You get relativity, you get quantum mechanics. However, the problem we humans have is rule number 5. We do not understand how the forces work because we have this discontinuity where quantum mechanics meets general relativity. We do not have the grand unified theory of everything, right? So because we don't understand number 5, we cannot do number 7. We cannot run the simulation and make predictions about human behavior based on the initial conditions of the universe. And I'm following. I get it. I'm in this thought experiment. I see where all the rules came from. I get it. But then he makes this leap. Let me read it to you. Whether divine intervention takes place or not, and whether our actions are controlled by free will or not, will never be decidable in practice. It is thus suggested here that where we succeeded in guessing the reasons for many of nature's law, we may as well assume that the remaining laws, to be discovered in the near or distant future, will also be found to agree with similar fundamental demands. Thus, our suspicion of the absence of free will can be used to guess how to take the next step in science. Okay. So he says these rules are obvious, but also these rules obviously cancel free will. So we can use the fact that we don't have free will to take a step forward in science. What he's saying is that quantum mechanics must not be the ground truth. Sometime in the future, we will discover a hidden variable or a new symmetry or some new type of math that will not only explain why our current methods make quantum mechanics probabilistic, but it will also supersede that, and we will no longer have a probabilistic theory of atomic behavior. Quantum mechanics will be replaced by a theory that's much more classical, but will explain the results that we get of quantum mechanics right now, which of course any successful theory would have to do to replace quantum mechanics. And of course, once we have that much more classical version of quantum mechanics, finding a grand unified theory will be so much easier, and then we could do step 7 and be God. He's already ended the thought experiment. That's obviously the natural conclusion. The new theory, Gerard Hooft says, will be 100% predictive. And that solves the determinism problem because the universe, the laws of physics are deterministic. And that's the end. And sure, fine. I do have 2 problems. First, I'm sure that this is addressed somewhere in some literature of physics philosophy, but I'm just gonna say it. I think when you're planning a giant simulation like the one God is doing in his example, you have to think about nonlinear dynamics and how chaos depends so much on little shifts in your initial conditions. I think about how tiny shifts in initial conditions, tiny shifts in your grid size, that radius of influence he was talking about, tiny shifts in whether or not you're using double precision or how accurate your results are. A lot of systems are nonlinear, meaning 7th order terms or 17th order terms become important. And when you're running a simulation, it is chaotic and you can't predict with 100% accuracy what will happen. This is sometimes called the butterfly effect, but I think that's misleading because the butterfly effect makes it sound like it's always a huge thing. But a lot of times, the little tiny difference just leads to a little tiny difference. And that's okay for your simulation, but it also means you can't 100% predict where particles will be. And this is again what Laplace was talking about. We will never have the intellect to create that simulation, but also, is it even possible? I'm not convinced that a future society or a god would have the computing power to run an entire universe with accuracy that you would need to predict what would happen exactly. I am with Laplace on that one. I just think this is outside of our reach, and it's fantasy to talk about this as if it would actually be possible, even in the case of you or a god. But the second thing, I think, when I look at these little rules and this little thought experiment is just duh. Oh, you think quantum mechanics might not be the final answer? You mean if someone came up with something better that not only explained away the probabilistic nature of quantum mechanics, but was more classical, you think that would be more interesting and beautiful to scientists? What? Oh my goodness. What kills me about this essay, this discussion, even though I agree with nearly everything he said, I don't really agree with his conclusion, but maybe he convinced me if he talked to me about chaos. But the thing is that this is a 100-year-old discussion in physics. The people who discovered or invented, that's a philosophy question, quantum mechanics, Einstein, Schrödinger, Planck, they were having these discussions 100 years ago, and they have continued to modern day. The idea that quantum mechanics is probabilistic and that makes a certain kind of physicist unhappy is just undergrad physics stuff. People who work today in experimental physics run experiments looking for examples of quantum mechanics that break this rule because they would very much like to come up with that better, newer theory of quantum mechanics. Of course, quantum mechanics, very successful, very predictive, really, really good. It might be the right answer. It's so good. But that doesn't mean physicists have stopped looking for the next step, the better version beyond the standard model type stuff. This is just common sense. The thing about 't Hooft's essay is that it's not provocative or progressive. He presents the idea to the philosophers at this conference like it's so radical for him to be like, maybe quantum mechanics isn't the final answer. But I'm so sorry to this man in 2016. That is not novel or even interesting. That wouldn't even be a novel idea in 1925. Just like, yeah, dude. Yeah, everyone thinks that. And this is where the grift comes in. Because the framing of this essay is that no one is listening to him. The other physicists just think everything's probabilistic and no one is listening to him. All the physicists are dum-dums and he has the answer. He's the only man ever in the year 2016 to think, hey guys, what if quantum mechanics isn't the final answer? He literally calls the other physicists baboons. That's a fun word to say, baboon. And this is the grift. He is creating a narrative in this talk where he's super smart and all the other physicists are dumb baboons and they won't even listen, they won't even open their eyes and look at the telescope. And this is just a very common grift with the online physicist, the podcast physicist who have an answer to the free will question. Like, no one will listen to me. Physicist hasn't done anything in 70 years. I lost my job and my grants because I'm telling the truth. This is why everyone in physics hates me, because I speak the truth. I think maybe you're just describing your brilliant idea that maybe quantum mechanics isn't the final answer, and you're mistaking the other physicist's response of boredom with disdain. But then he called us baboons, so it seems like a choice. Like, see, chat, I'm the only physicist that'll tell you the truth. I'm the only physicist in the world who thought maybe quantum mechanics isn't the final answer. Buy my book. He does have a book, but it's free though, and it outlines this idea, but in like more physicsy terms. And his solution is automata, which really it gives Wolfram Alpha, which is not that guy's name, Stephen Wolfram. It's silly. Anyway, they are creating an audience of people and trying to shelter them from the world of actual physics by being like, I'm the only one that will tell the truth. I'm the only one that has the answer to free will, which isn't even a physics question. I'm the only one speaking truth to power. And it's just like the physics community is like, dude, it's just that you're not saying anything interesting. Like, oh, you think maybe it would be cool if there was a classical version of quantum mechanics that worked and wasn't probabilistic? Yeah. But do you have the hidden variable? What's the hidden variable? What is it? How can we measure it? Have you taken a second step, or are you just saying, man, it would be cool if we had a different quantum mechanics, because that's useless? And also, they've been saying that for 100 years. You're sitting there chattering in your single author quantum philosophy response papers while the other physicists are like doing experiments and stuff. Maybe that's why they're not talking to you anymore. I'm back on my science communication bullshit because this is a science communication issue. And here's my tip. If a physicist is on a YouTube like I am right now, and they look you in the face like I am right now, and they're like, this is why physicists hate me. I'm the only one speaking the truth. It's a grift, but like obviously it's a grift though. If you heard a medical doctor be like, no other medical doctors would listen to me, apple cider vinegar cures cancer, you would know that that's a scam, right? So why doesn't it work with physicists? What's going on there? They want you to buy their book. They want you to click on the clicks. They want you to click on their links. And it just seems weird. It seems counterintuitive. Like, if you're doing science communication, why are you shitting on all the other scientists? But like, maybe they're not doing science communication. Science is collaborative. You don't like silo yourself and then be like, no one will listen to me. I have the answers. Anyway, all of that to say, any physicist saying they have a definite answer to the free will question, it is just the reddest of red flags, because that's not even a physics question. They're just willing to say anything in public that's controversial so that they stay in public as like, oh, that one physicist who will say anything. And whatever. So let's wrap up. Is free will a physics question? I don't think so. It's kind of related through determinism, but I don't understand how physics determinism relates to the free will discussion of the brain. And I would love to learn about that. I would love to know how the brain works. I'm excited to see where that research goes, but I don't think as a physicist I am able to answer that question at all. I will tell you one thing though. I read these 3 books, I watched a bunch of physics YouTube videos, and me mocking what I'm making at the same time. Classy. Oh, I suck. Anyway, I also watched a bunch of philosophy lectures, and all the media I consumed about free will failed to do one thing. It failed to convince me that the question of free will is even an interesting or fun thing to think about at all. This book has a theology chapter, and the whole time I was reading the first half, I was like, of course, Christian theology, it's going to talk about Adam and Eve. Like, they had the free will to eat the apple or whatever. And then I got to it, and it's just about Jesus. It's just about Jesus. It's really weird. Anyway, I thought it was interesting that the religious guy was the only one that said free will existed out of all these people. That's interesting, right? There's something there. All right.